So right now we are starting to get into one of the main parts of calculus. We're going to start talking about derivatives. But before we do that, we need to talk about average and instantaneous rate of change and what those are. So for the first 10 minutes of class, I'm going to have you guys work on these couple problems. But just to kind of remind you and maybe help get you started on how to do something like this. Let's look at an example. So let's say we had f of x is equal to some function, I don't know, x squared minus 2x plus 1. And if it wanted us to find f of negative 1, all that's telling us to do is to go back into this equation, and wherever we see an x, we're going to replace it with a negative 1. So I'm just going to go through my equation. I just kind of put parentheses wherever I see an x, and I write everything else down. So I see an x, parentheses, I square it, minus 2. I see an x, so a parentheses there, plus 1. And then I'm going to go in and I'm going to replace, put inside that parentheses, that negative 1. So now we're going to use order of operations to simplify. And so exponents come first, so negative 1 quantity squared is 1. Negative 2 times negative 1, so plus 2, and then plus 1. So 1 plus 2 is 3, plus 1 is 4. So f of negative 1 is equal to 4. Basically, this is a point on the graph. When x is negative 1, our y value is 4. If it told you to do something like f of a, all that's telling me to do is go in there, and wherever I see an x, instead of plugging in a number, I'm plugging in a. So again, I'm just going to go through wherever I see an x in this original equation. I'm going to put parentheses. So I have a x, so parentheses, then squared, minus 2, parentheses, plus 1, and then just replace it with a. There's nothing here I can do to simplify this because a squared and minus 2a are not like terms. They have to have, a has to be raised to the same power to be like term and to combine them. So this is as far as I could take this one. So one more example. What if it said find f of x plus h? So in this case, we're going to go in, and instead of plugging in a number or just a variable, we're plugging in that whole expression, x plus h. And so again, I'm going to go through wherever I see an x, I'm going to put parentheses. I'm going to leave enough more space though. Minus 2, I see an x, so parentheses plus 1. So now go through and plug in x plus h wherever you have that parentheses. This we can simplify a little bit. So be careful, x plus h quantity squared. I can't just square both of those terms. That's telling me to take everything in that whole parentheses and multiply it by itself twice. So x plus h times x plus h. I can distribute, and when you're distributing, make sure you carry the sign in front of the number. So distribute the negative 2 to that quantity x plus h. We get negative 2x. Minus 2h plus 1. And so let's distribute. So x times x is x squared. X times this h is plus xh. H times this x is hx, but I can also write it as xh. And then h times h is h squared minus 2x minus 2h plus 1. So go through, see if there's any, oops, it's minus 2h. See if there's any like terms. So there's no other term that it has an x squared in it, or so I would just bring it down. Here though, I have an xh plus an xh, those are like, so 1xh plus 1xh is 2xh. I don't see any other h squared in here, so I'm going to bring it down. So h squared. I have a minus 2x and a minus 2h and a plus 1. And this is as far as we can take this. So any questions on that before you guys try it with those 4 problems? Anything you need cleared up or?
Just that on the very first one,
Mm-hmm.
so we would plug in the h plus 5 where all the x's are, so that when we multiply it out like you did here down on the bottom, but we still would need to multiply it times 2, correct?
Correct. Right. So like I was saying, so let's say instead this had a 2 out here. And so you would have to FOIL this out and be careful, make sure that you have brackets around that whole thing and then distribute it to each term. So she's talking about this 2 out in front of this x squared here when you're dealing with this. I'm going to take out that 2 just because it wasn't in my original. Okay. So go ahead and try that. And I'm going to just pause the video while you guys are working. Okay, so we're going to just go back into this example and f of x, and let's now look at it. Let's say we wanted to evaluate the following. It tells us that we want to look at f of 2 plus h minus f of 2 all over h. And again, we're going to use this same function, f of x up here, x squared is equal to x squared minus 2x plus 1. Sometimes students find it helpful to do this in pieces at first. And so let's first look at f of what 2 plus h is saying. So same kind of idea. We're going to go in here, and wherever we see an x, we're going to replace it this time with the expression 2 plus h. So let's just go in wherever we see an x in this equation, we're going to just put parentheses. So I see an x and that quantity squared, so parentheses squared, minus 2, I see an x there, so I'm going to put a parentheses plus 1. So let's go in and plug in 2 plus h wherever we see the parentheses. And then let's simplify that. And so simplifying that, let's distribute this out. So we really have 2 plus h all times 2 plus h. Let's distribute this negative 2 inside this parentheses. So we have negative 2 times positive 2. So this is negative 4. And negative 2 times positive h is minus 2h plus 1. So foiling this out, we have 2 times 2, which is 4. We have 2 times this h, so plus 2h. Distributing now the h to each term in the second parentheses, we have h times 2, which is 2h. And then h times h, so plus h squared. Minus 4, and let's bring down the rest, minus 2h plus 1. We can simplify this a little bit because we do have like terms in here. And so notice, let's just look at the constants first. We have 4, minus 4, and a plus 1. So that's just going to give me a positive 1. And then I have 2h plus 2h. This gives me plus 4h.
Where did the negative 2 come from?
Yeah, this negative 2h right here. Is that what you're looking at?
The purple, this negative 2 you have circled in purple?
Yeah, that negative 2 came from outside of this function.
Okay. I was looking at the function for the problem, and I saw 3, so I got myself confused.
When you said that, though, I see I have a 2h plus a 2h and actually a minus 2h. So that's actually going to only give me a positive 2h. And then I have this just h squared. And then that's it. So this is the f of 2 plus h piece. it wants us to look at what is this negative f of 2. So negative f of 2. So what this is telling me to do is wherever I see an x, I'm going to be plugging in 2. But this is negative in front of my function, f of 2. So go in here wherever you see an x in our function, which is this x squared. So I'm going to put a parentheses. I'm going to plug in 2 and square it, minus 2. I see a x, so I'm going to put a parentheses, plus 1. So this is equal to negative. So 2 squared gives us 4 inside here. Minus 2 times 2, so that's plus 4. And then plus 1. Actually, sorry, that should have been 2 squared is 4, but negative 2 times 2 is minus 4 plus 1. I knew something was wrong looking at it. So simplify inside our parentheses. Negative 4 minus 4 cancels, plus 1. So we have a negative 1 here. So if we look at this whole piece in here, let's put it all together. We found what f of 2 plus h was. That was this piece right here. So this would give us, let me just put it together again. So f of 2 plus h minus f of 2 and then we have all over h. So f of 2 plus h we found was 1 plus 2h plus h squared. This minus f of 2 we found was minus 1, and we put it all over this h. So notice in our numerator, we do have like terms 1 and negative 1, and they cancel. And so we technically have, I'm just going to write it in descending order of power, h squared plus 2h all over h. Notice we can factor out an h from both of the terms in our numerator. So if we pull out an h there, we're left with an h plus 2 all over h. And so since this is multiplication, I can simplify because we have like factors of h in the numerator and denominator. And so this is just left with h plus 2. So you're sort of doing the same sort of idea with the W2 and W4, those warm-ups. Any questions on that? Okay, so hopefully that will help you finish up if you needed that. Let me just pause the video again. Unfortunately, to blow that up, I kind of got rid of the other piece below. Find my mouse. Okay, so I have the answers here on the right. And then we're just going to go through and let's just look at W1. And then I'm going to get into the material for this section. And actually doing some of this in the next chapter, our next section after this one, 3.3, will also help clarify, and we'll get a lot of practice of doing these. So we have f of x is equal to, and I'm just going to write it down below. So I have room. F of x is equal to 2x squared plus 3x plus 4. And we want to look at f of 5 plus h. So what we're doing is wherever we see an x in this function, we're going to go through and we're just going to put parentheses where that x is. And that's what we're going to replace with this whole expression x plus 8, or 5 plus h. And so I have 2. I see an x here, so I'm going to put parentheses. And then that x is squared, so I'm going to put a square above that parentheses. Plus 3. I see an x here, so I'm going to put a parentheses. And then I have this plus 4. So inside the parentheses, let's put in this 5 plus h. So order of operations says that we have to do exponents before we do multiplication. We cannot distribute this 2 inside this parentheses because of this exponent here. And so let's just rewrite this out. This is really saying 2 all times 5 plus h times 5 plus h. And then we have plus, there's no sign in between this 3 and this parentheses, so that's telling me I need to distribute this 3 and its multiplication to each term inside the parentheses. So we have 3 times 5, which is 15, plus 3 times h is 3h, plus 4. So I can either distribute this 2 first into one of the parentheses and then distribute, or I can leave this 2 out here for now. And I can go in and I can distribute these 2. So if I distribute the 5 to each term in the second parentheses here, I have 5 times 5 is 25, plus 5 times h is 5h. So distribute the h to each term, so h times 5 is plus 5h. And then h times h gives us plus h squared. So let's end our bracket, plus 15. I guess I can combine like terms, but I'll just write it. So plus 15 plus 3h plus 4. So let's combine like terms inside the bracket. I notice there's 2 like terms, the 5h plus the 5h. I'm just going to rewrite this descending order of power. So I'm going to write my h squared first. And we can rewrite the sum of things as long as we're carrying the sign in front of them. And then we have a plus 5h plus 5h gives us a plus 10h, plus this 25. Then in our bracket outside, let's just combine some like terms here. We have a 15 plus a 4. So this is a plus 19. Plus 3h. So we're almost there. Let's distribute the 2 inside the bracket. So we have 2 times h squared is 2h squared, plus 2 times 10h, so this is plus 20h. 2 times 25, so that's plus 50, plus 19, plus 3h. So combining like terms, there's no other h squared terms, so we have a 2h squared. We have a 20h plus a 3h is a 23h, so plus 23h. And then we have a 50 plus 19, which is plus a 69. So this is what f of 5 plus h is.
Okay, I definitely see where I went wrong. Thank you.
You're welcome. Okay. So we're getting into the next piece, which is finding the average rate of change on between 2 points on a function and finding the instantaneous rate of change. So let me just kind of give you an example. So let's say you are driving to Sacramento, and you know from Yuba City to Sacramento, it's about 40 miles, and it took you an hour to get there. Could you tell me how fast you were going? So you travel 40 miles. In 1 hour. How fast? Where are you going? Could you figure that out? So you might remember the formula that distance is equal to rate times time. Well, if we know, and rate is the speed, and if we know that our distance is 40 miles and our time is 1 hour, well, we can plug those into the equation and solve for R. So we know that 40 is equal to the speed we were going times the time we were traveling, which is 1. And then if I divide by, well, I don't really have to divide by 1. So I know that R is equal to 40. 40 miles per hour. But do you think that you were driving 40 miles per hour the whole time that you were traveling to Sacramento from Yuba City? I kind of doubt it, right? You're gonna hit some stoplights, you're gonna hit some maybe traffic, hopefully you're slowing down sometimes, you're speeding up. So you're not really going 40 miles per hour. That's your average rate of speed is what they're telling us there. So calculus is going to give us the tools to find out how fast you are going at a particular time, which is going to be called the instantaneous rate of change. So maybe we wanted to know your exact speed 25 minutes into the trip. And with calculus, we'll be able to calculate that with information that we're given. So first, we're going to look at the average rate of change, and then we're going to get into the idea of what it means to have the instantaneous rate of change. This kind of example was kind of bringing into where we're going and why. For business reasons, maybe you're looking at revenue and how much revenue you get when you sell 100 items. And you want to know, okay, with, what would the revenue be if I sold 2 extra items, 102 items? Or what would the revenue be just at that 101st item? So this would be some tools that we can use with calculus. So before, we can only find the slope or the rate of change of a line, and that would always be exact. But for example, let's say you have some function here, and we wanted to find the average rate of change between x equals a and x equals b. So basically what we're doing is we're looking at the point here. And so this point right here, our y value is f of a. And this point here, f of b, this is our y value when x is b. This would be f of b. So when we're looking at the rate of change, we're looking at the slope of the line between these 2 points. So recall to find the slope of a line. So to find the slope of a line, a line between 2 points, in this case, I'm just going to call them what my 2 points are here. When x is a, my point is a, and when my x is, when x is a, my y value is f of a. And my other point here is when x is b, so b, comma, my y value is f of b. We're looking at the change in our y value. Well, the change in our y value is looking at the y value, f of b, minus f of a, all over a minus f of b. I'm sorry, a minus b. Okay, so that would give us the slope between these two lines. And this would give me the average rate of change. So this is the average rate of change. Between x equals a and x equals b on f of x. So I'm just going to bring in the terminology now. But this line right here that we drew between the 2 points, we're trying to find the average rate of change. This is called the secant line. Okay, so the line that joins the 2 points. You are finding the average rate of change for. Is called the secant line. So if you don't remember, and I'll quickly go over it, not right now, but you'll need to know it for next week, is you need to remember how to find an equation of a line. So if you know a slope of a line and you know a point on the line, you should be able to find that equation of a line. But for now, I'm not going to go over that because we don't need it. A second. So let's say you have a following function. And we're given that y is equal to x squared plus 2x. And they want you to find the average rate of change over the given interval. And this interval is going to be between x equals 1 and x equals 3. So average rate of change. Okay, so find the average rate of change between x equals 1 and x equals 3. So we need to find the 2 points. Well, let's figure out what our y value is when x is 1. So when x is 1, and this is where it's helpful to have this as function notation. We could say this is f of x squared 2x, f of x. So instead of me having to write this, I could just say, let's look at f of 1, which means wherever I see an x in my equation, I'm going to put a parentheses. And the reason I do this is because sometimes students want to leave the x in there when after they put the number in there, or sometimes they think it's like multiplication in there. So I found that maybe just going in and wherever I see an x or the variable of my function, and I'm replacing it with a number or with an expression or with a variable, I first go in and just rewrite it without that x. The x is just being replaced with a parentheses. And this is just saying, now we're going to look at when your x value was 1, what is y? So order of operations, please excuse my dear Aunt Sally. Parentheses already simplified. Exponents, so 1 squared is 1. Then multiplication or division in the order it comes left to right. So 2 times 1 is 2. Addition and subtraction, order it comes left to right. So 1 plus 2 is 3. So we have a point at 1, 3. So now let's look at what is f of 3. So again, just go in wherever you see an x, we're going to rewrite it within a parentheses. So x squared, so parentheses squared, plus 2 times x, so 2 parentheses. Go in there and replace or put in the 3 inside the parentheses and then simplify. So 3 quantity squared is 9 plus 2 times 3, so that's plus 6 equals, so 9 plus 6 is 15. So here we have a point when x is 3, y is 15. So the rate of change, another way to write this, we're looking at the change in your y value all over the change in your x value. So y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Just be consistent with which point you start with for your y value is the same point you need to start in the denominator with the x value. So in this case, if I started with 15 for my y value up here, I'm going to start with 3 down here for my x value. So 15 minus 3 all over 3 minus 1. So 15 minus 3 is 12 all over 3 minus 1, which is 2, which simplifies to give us 6. So the average rate of change between x equals 1 and x equals 3 is 6. Let me just think about that graph for a second. Let's look at it. So I noticed that x squared plus 2x, we have a parabola. I know that my parabola has to be facing up because that coefficient in front of the x squared was positive. So let me just look at f of x for a second so I can just show you what we just did. I also noticed that if I'm looking for my y-intercept, that's I can factor this function. So let's pull out an x. They both have x squared plus 2x has an x in common. I'm just doing this so I can figure out what is my y-intercept and my x-intercept. My x-intercept would be at 0 and -2. My y-intercept is at 0. Vertex formula, you really don't need to know this right now, but it's -b over 2a and f of -b over 2a. So my b value, my function go, is 2. So h would be -2 all over 2 times 1 is 2. So my h value is -1. And my guess is that's when x, yeah, x is -1. So if I look at f of -1, I can figure out where my y value is there. So that would give me, I see an x, square it, plus 2. I see an x. Let's plug in -1, we get 1 minus 2 is -1. Okay, just wanted to graph it really quick. We also found 2 points up here. We knew that there was a point at 1, 3. And we knew that there was a point at 3. I wasn't thinking about this, 15. Okay, way up here. Oops, pretend that's not squiggly. So what we just did is we took and found the average rate of change between this point and this point. So we found the slope of the line if we were to join these 2 points. And our slope would be a rate of change of 6. So basically, we would have to rise up 6 for every one, rise up 6 for every one that you went over to the right. In my graph, that looks pretty darn close to what that slope of that line is, but if I maybe had extended it out where my units were bigger, you would see more of the difference, that it's not the same exact line. Okay. So let me just give you the overview real quick of what we're going to be trying to do and how we can use our limits to help us. I just really want thicker pens. So let's say we have, again, some function. Let's say that we have some x value here. And let's just go out here a distance of h. So if we added a distance of h to our x value, really then this point right here, it would be x plus h. This x length plus this h gives me this x value. Okay, so this value right here then, this would be f of x. This value right here is f of x plus h. I'm just going to write my point out generically. This is x, this is f of x. This is x plus h is my x value, and f of x plus h. Well, if I took the slope between those 2 points, so that's the change in my y value. So that would be my f of x plus h minus my y value for the other point, which is f of x, all over. So I started with this x value for my slope, so x plus h minus my x value for my other point, which we said was x. So this kind of simplifies down a little bit. F of x plus h minus f of x all over, well, x plus h minus x. These x's are going to cancel and just leave me with h. So it might look a little familiar to you. And what we were just finding was that slope between those 2 points. So if I look at that, that gives me a kind of a good estimate of how fast that slope is rising here between those 2 points. But let's say I wanted to know exactly what was happening here at x. Well, notice if you take that limit, we make the size of h get closer and closer to 0. So if that line, this h value, that distance is shrinking down and getting closer and closer to x, you know, if we put it here, this would give me a better estimate versus the green line. If I put it here, this point's now going to give me a better estimate of what's going on. So the closer and closer I make this h value, this point, finding that average rate of change, getting closer and closer here, the more accurate I'm going to get. So looking at this, if I look at the limit of f of x plus h minus f of x all over h, this is going to give me the instantaneous rate of change. This will give us the instantaneous rate of change. Anywhere on the function f of x. Where it's defined, but we'll get more into that later. Okay, so that's kind of the whole kind of reasoning behind looking first at the average rate of change and then making that interval smaller and smaller and closer together so that we can figure out what that instantaneous rate of change at a particular value is. And this is getting into the concept, the major concept of calculus, which is the derivative, which is another way of saying finding the instantaneous rate of change at a value. So let's take a break real quick. So we're looking again at the instantaneous rate of change. And let me just give you the formal definition. We were just talking about the difference between the average rate of change and the instantaneous rate of change at a value. And so let's say we want to find the instantaneous rate of change for a function. F as x equals a is the following. So we're going to look at the limit as h approaches 0 of f of a plus h minus f of a all over h. So again, you could have some function, doesn't matter what it looks like. Let's say that this is here a, this is f of x. Again, this would be our f of a value. And if we went out h, but that distance of h from here, this would be a plus h. This is f of a plus h. And so what this is saying as this h value, this distance between this, where we're looking at the average rate of change, shrinks as h goes to 0. This is going to give us better and better accurate result of what's happening, that instantaneous rate of change at x equals a. This right here, this line that joins or has the slope at a, this is called the tangent line. And the 2 points that you're finding the average rate of change between, I was doing it between here and here, and these 2 points, the line that joins those, we just defined as the secant line. Let's look at another example. No. Okay, so let's just suppose that the position of an object moving in a straight line is given by the following. S of t is equal to 5t squared minus 2t minus 7. So find the instantaneous velocity at each time. So this is an object moving on a straight line. And we want to find the instantaneous velocity. At, let's say t is equal to 1. So this is where we want to find the instantaneous rate of change when t is equal to 1. And so in this case, we're going to use this formula. The value that we're having a, what we're trying to find the instantaneous rate of change is 1 for our case. And so what we want to do, and our function in this case is equal to s of t instead of f of x. So what we're going to try to do is we're going to look at the limit. We need to find the limit as h is approaching 0 of f of, instead of a, we know we want to do it when t is 1. So 1 plus h minus f of 1 all over h. Oops, and I'm sorry, I just told you that my function was not called f, it's called s. So technically it should be written like this. If it helps you, we can do this in pieces. If you want to look first at what is s of h, s of 1 plus h. What this is telling me to do is we're going to go to our function s of t, and wherever we see a t, we're going to replace it with this 1 plus h. And so let's just go in there, and wherever we see a t, we're just going to plug in that. We're first going to just put a parentheses there. So first in this function, we have 5. Then you see a t here, so we're going to put parentheses enough to put in that whole expression 1 plus h. It tells me to square that, so square that parentheses, minus 2. We see a t here, so I'm going to put a parentheses so that we can go back and replace it in a second with 1 plus h, and then minus 7. So going back in here and replacing inside the parentheses, so we're going to put 1 plus h. So we want to simplify this down. It's easier if we do that now instead of later. And so let's figure out what 1 plus h times 1 plus h is. So rewriting this, I have 5 times the quantity 1 plus h times 1 plus h. Same time, I'm going to simplify over here. So let's distribute. There's no sign between that -2 and this parentheses. So we have to distribute this negative, carry the sign. So we have -2 times 1. So that gives me -2. And we have -2 times h. This is -2h. And then we also need to bring down that -7. I'm going to leave the 5 alone for a second, and let's distribute the 1 plus h times 1 plus h. And so 1 times 1 gives us 1. 1 times h gives us plus h. H times 1 gives us plus h. And h times h gives us plus h squared. Close off our parentheses. I notice out here, I have 2 terms, -2 minus 7. They both have the same sign in front of them, so we add them and keep the sign the same. So -2 minus 7 gives us -9. And then right now, there's no other term with just an h. I need to bring it down, -2h. So let's distribute that 5 that's outside that parentheses. Actually, before we do that, maybe we can clean up inside that parentheses first. So we have 5 parentheses. There's 2 like terms inside this parentheses, h plus h. And I'm going to rewrite it as h squared and h plus h, so that's plus 2h. And then the plus 1. Close off the parentheses, -9 minus 2h. So let's distribute the 5. So I have 5h squared plus 10h plus 5. Bring down the -9 and -2h and combine like terms. So what do we have? We have just a 5h squared. We have a 10h minus a 2h. That gives me a positive, so plus 8h. And then I have a 5 minus 9. Larger number has a negative in front. We're going to subtract 9 minus 5, that's 4. A larger number has a negative, so it's going to be -4. Okay, so that was just my S of 1 plus h. You can come back and grab that in a minute. And I'm just going to box it off so it's easier to find it. Just did this piece. And so now we want to look at minus S of 1. I can just look at S of 1 now and then deal with the negative later. Or we can look at the negative of S of 1, which means that we're just going to have to go back in, plug in 1 wherever we see a t in S of t, and then distribute at the negative. Let's just look at S of 1 first. So S of 1, that's telling me to go in wherever I see a t in that function S of t. I'm going to put a parentheses and I'm going to replace it with a 1. And so this is equal to 5 times, I see a t there, so I'm going to put parentheses. That t is going to be squared. So -2, I see a t there, so put parentheses -7. Place wherever you saw the t, where we put the parentheses with a 1. Order of operations, exponents first, 1 squared is 1. And then 1 times that 5 in front of it gives me 5. -2 -7. So working left to right, adding or subtracting, 5 minus 2 is 3. and 3 minus 7. Well, 7 minus 3 is 4. Larger one had the negative. So this would be negative 4. So this is what our S of 1 is. Let's go back in to this and rewrite it. So right now we're looking at the limit as h is going to 0. Well, S of 1 plus h, that was the 5h squared plus 8h minus 4. And then minus S of 1. So S of 1 right here, we said was negative 4. So minus a negative 4. And then it tells us to put this whole thing all over. I'm going to put h in the denominator. Okay, recall if you have a minus and negative is the same thing as saying we're going to add. So let's just simplify this a little bit. So this is the limit as h goes to 0 of 5h squared plus 8h. Well, negative 4 plus 4, those cancel out with each other, all over h. We can use our limit laws. We have a polynomial in our numerator. We have a polynomial in our denominator. So we could look at the limit of the numerator as h goes to 0, all over the limit as h goes to 0 of the denominator h. But if we did that, we get that indeterminate form, that 0 over 0. So remember that didn't tell us anything, and we had to go back in and we had to manipulate it. So if we get the 0 over 0, that's going to tell me that there's a factor in common usually. And so one way we can do that, and we will have factors if it's a polynomial, we can factor out an h in our numerator. They both have an h in common. So if we pull out an h from 5h squared, we're left with 5h plus, and if we pull out an h from 8h, we're left with just 8 all over h. Notice those h's cancel. So we're really looking at the limit as h goes to 0 of 5h plus 8, which is equal to, so plugging in 0 wherever you see an h, get 5 times 0 is 0 plus 8 is 8. So the instantaneous rate of change, or how fast the velocity is at time of 1, I don't know, it didn't say time in hours or whatever, or minutes or seconds, is going to be 8. So the velocity of the particle at t equals 1 is 8. So I could be a little more specific there if I knew what t was representing in terms of time, and if I knew what s of t was in terms of position. Was that distance meaning feet, miles, inches, etc. So we can also use this in business. And so let's look at, hopefully, which it will be a quick example. Let's look at profit. So suppose that the profit in hundreds of dollars by selling X items is given by the following. So P of X is equal to 2x squared minus 5x plus 6. Okay, so find the average rate of change of the profit for the following changes in X. So we want to find the average rate of change. From X equals 2 to X equals 3. Okay, so basically we need to find those 2 points. And we have our function here, P of X. And so we need to figure out what is P of 2, and we need to figure out what is P of 3. Let's just go in here, rewrite this, and put a parentheses wherever we see an X, and then we'll go back and rewrite what the number is that we're going to plug in. So we have 2, we see an X, so put parentheses, and then square it. Minus 5, you see an X, so put parentheses, plus 6. So when X is 2, we get the following. So we get 2 times 2 squared. Well, 2 squared is 4. So 2 times 2 squared, 2 times 4 is 8. Minus 5 times 2, so minus 10, plus 6. So 8 minus 10 is negative 2. Negative 2 plus 6 is 4. And now we want to look at P of 3. Should I write this before I do P of 3? So we know we have a point at 2, 4. So let's look at now P of 3. Go in, plug in 3 wherever you see an X and P of X. So we get 2 times 3 squared. Well, 3 squared is 9 times the 2 in front is 18. Minus 5 times 3, so minus 15, plus 6. So 18 minus 15 is 3. 3 plus 6 gives me 9. So we have a point at when X was 3, Y is 9. So the average rate of change between those 2 points. So 4 minus 9, change in my Y value, all over 2 minus 3. 4 minus 9 is negative 5. All over 2 minus 3, which is negative 1. So this is equal to 5. In here, and I didn't put it up here, but it said that X was in terms of, or actually, suppose that the initial profit in hundreds of dollars. Profit is in hundreds of dollars. So this is really dealing with a profit of 500. So between, and it didn't tell me the items were in terms of anything, just so X items between 2 and 3 items. So part B, so find and interpret the instantaneous rate of change of the profit respect to the number of items produced when X is 2. So it wants to find the instantaneous rate of change when x is 2. Okay, so I'm not going to have time to do this, but let me just set it up. So looking at this, we want to look at the limit when h is approaching 0 of our function p. So it's going to be p of, in this case, it's going to be 2 plus h minus p of 2 all over h. If we did this, this is giving us 300. $300 per item. At x equals 2. Okay, so that would be the profit is $300 if we're going to sell an additional item when x is 2. Okay, so we pretty much got through 3.3, which talked about instantaneous rate of change first, and we derived that from looking at the average rate of change and taking that distance and shrinking it down so that we know what's happening at a particular value.